Welcome everyone again to our math workshop sponsored by Cash Prep. I am Mr. Sam again, and we're just going to go ahead and get started immediately. We're going to go ahead and share the screen. We've already had our pleasantries, so we can go ahead and get started. So what we're going to do, as always, we always try to reach back a little bit each week to what we've done already, just to make sure that it's still fresh with us. So what we will start off with is on the right side this week. We'll start off on the right column, and we will start with the Trina question. It says Trina wants to write 1/4 and 1/6. There's like fractions, and the question what are the like fractions? So anyone can tell me what the correct answer is, and then also how we get to it. And I know we're a little short in here today, but which means that I need more participation from each one of you. All right, so let's go ahead and participate.
The like fractions would be 3/12 and 2/12.
Okay, how'd you get that?
Because if you multiply the 4 times 3, you get 12, and whatever you do to the bottom, you have to do to the top. So I multiplied 3 times 1, and you get 3, so it becomes 3/12. And then I did the same thing for 1/6, which is 2 times 6, which is 12, and 1 times 2, which is 2, and that becomes 2/12.
Okay, perfect. Thank you for that. Okay. Next one we have which number sentence is true, and so we're looking at comparing integers, or comparing fractions, I should say. I'm sorry about that. Comparing fractions. Integers is our next topic for the next hour. And so I want to compare fractions, and it's asking me to determine which number sentence is true. Now, I'm going to take a look at this and, make some rough estimations, and then I'll try to prove my answer. Okay. If I'm looking at, I'm going to start from A. 1/3 is greater than 4/10, right? So 1/3 is greater than 4/10. Based on what I kind of know about fractions and the way it works, 1/3 should be less than 4/10, right? 4/10 is almost half of 10. So, right, if I have 4/10, if I ended up with 5/10, I'd be a half. And then I know a half is greater than a third. So I'm going to say that this is incorrect. Okay. I'm going to jump down to D. Okay. D says 1/4 is less than 2/8. I know that actuality 1/4 is equal to 2/8, so I can cross this out. So my process of elimination strategy kind of leaves me with these two. And now again, 4/9 greater than 1/2. I know that 4 is not up to half of 9, right? So 4.5 actually is half of 9. So I'm going to go with this being incorrect. And then I'm going to go with 3/8 is 3/8 is less than 2/3. And this is going to be my correct answer. Now to prove it, all right, to be clear about, again, I kind of did approximations. To prove it and to be clear that I'm actually correct, I'm going to go ahead and find equivalent fractions. So for 8 and 3, the LCM, least common multiple, would be 24. So 3/8 So I need to multiply this by 3, multiply that by 3. That's going to give me 9/24. And for 2/3, multiply this by 8, multiply that by 8, and I get 16/24. All right. So that proves that my answer is correct. One of the things that this question also tests is, can you read your inequalities, right? And so just to kind of go over inequalities, when we're looking at, let's say, A and B, open mouth always to me represents, or open side, we call it open mouth, always should represent the larger side, just visual, right? This side is larger than this side. This is our point, so our point should be less than. So based on whichever way we're reading it, this should say 1/3 is greater than 4/10, because again, we're always going to go from left to right. 4/9 is greater than 1/2, is how we evaluate that. On this one now, we have the less than comes first, so we're going to say 3/8 less than 2/3, and 1/4 less than 2/8. All right, so just quick review of our inequalities. Okay, so again, just to kind of write it, our open side is greater than, this side is less than. In algebra, you'll sometimes also come across this sign here, which is same, but there's an equal sign here. So we would read this as greater than or equal to, and then if we saw something like this, this is less than or equal to. All right, just something to be aware of. It will show up at some point in the future. All right, moving on with our review. Good evening, Justin. How are you today? All right, so moving on with this, ordering from least to greatest. Again, what we want to do with this is, I could do some approximations here, but I won't. Matter of fact, you know what? Yes, I will. I'm going to go ahead and do some approximations here. First of all, I know that I'm going to use 1/2. I know 1/2 represents a middle, right? Or 0.5 or a half. So if I look at 3/5, 3 is more than half of 5. So I'm going to go say that 3/5 should be over here. And if I look at comparing 1/2 and 9/20, well, half of 20 would be 10. So 9/20 would be less than 1/2. And then 3/10, right? So comparing 3/10 to 9/10, if this was equal to 20, this would be 6/20. So that also is less than 9/10, 9/20. So I should say just less than. So I would have 3/10 as my lowest value, then 9/20, then 1/2, and then 3/5. So you can always do some, fairly strong approximations with fractions, depending on how close they are to each other. There's some basic rules too to be aware of. So for instance, if I'm going to ask my audience, so audience, I need your participation on this. Which one is greater, 6/7 or 5/6? Anyone?
Six over 7.
6/7, that's correct. Why did you say that?
I just really guessed the answer, but I would say, I think I said it because if it was like in like a diagram form,
Mm-hmm.
I feel like 6/7 would be larger than 5/6.
Okay. Why? Why? I, you're absolutely correct, and your concept in terms of you thinking about it in diagram form is perfect. But I just need you to kind of close it out. Why is that?
Because um
If these were pies, right? 5/6. How many slices would be in the pie?
would be 6 slices,
6 slices, right? 6/7. How many slices?
7 slices.
So when the denominator is larger, the slices are smaller, right?
Yes.
The actual number, because you're cutting the same pie, you're cutting that same hole, but this time you're cutting into 7 pieces, right? In this case, you're cutting into 6 pieces, right? So these the smaller denominator gives you larger pieces, right? Now, when I end up with 6/7, that means all that's left is this little small piece that's 1/6, right? That little small piece of 1/6 is smaller. I mean, of 1/7. I'm sorry. That little piece of 1/7 is smaller than 1/6, which means that 6/7 is greater than 5/6. All right. And the same thing would keep holding true. So what about 7/8, which would be larger?
It would be 7/8.
Right, 7/8 would be larger. And what about 8/9?
8/9 would be larger.
Exactly. Okay. Over here could be 4/5. So whenever you have to compare these kind of fractions where it's like almost to the very end, or in the opposite direction, if you had 1/2, 1/3, 1/4, 1/5, 1/6, you know that as you increase the denominator, if your numerator is the same, the number with the larger denominator is going to have the less value. Okay. And again, that holds true even if we move away from 1. If let's say we did 2 as the numerator, and I'm gonna get back on topic in a second, but I just think like math is really fascinating because you can pick up so many different patterns from it. So again, if I have same denominators are increasing, but the same numerator, I see that the numbers with the smaller denominators are larger because 2/2 is actually equal to 1, right? And 1 is greater than 2/3. 2/3 is greater than 2/4, which again is 1/2. 1/2 is greater than 2/5. 2/5 is greater than 2/6, which is 1/3. And you have that consistent property going on. So if you ever come into a situation where you have something like this, you may not necessarily have to go through the whole thing of evaluating the expressions, changing them to like denominators, blah, 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 blah. All right. So just using um, some math facts, right, can help us get to those answers. All right, so let's move on to the next piece. So this week we finally get to, we've been working up to adding and subtraction fractions, so we finally get to do that. Let's see. All right, so Ariana, I think you're going to be helping me a lot today because I'm not seeing some of our regulars. Ash just there, but something seems to be off with her phone. I mean, her mic. Justin is actually there. Justin, you didn't acknowledge yourself the other day. I mean, a few seconds ago. All right, so here we go. So Justin, you've been quiet, so it's time for catching up. We're adding these fractions, Justin. We got 3/8 plus 3/8. What do you come up with?
6/8.
The 6/8. There we go. And is this fine to just leave it at 6/8? We done?
I think. And some. Well, that's what I was learning. Yeah, I think.
Okay. All right. So we have this then in math where we're always looking for the simplest form of numbers. Okay. So your answer is not incorrect, but in math, anytime you have the opportunity to give a number in its simplest forms, we always take advantage of that. Now, when it comes to fractions, what we're how we do that is we take a look and see if there are any common factors. Now, let me just review. Factor is a process of what operation? Justin? Factors is a concept that speaks to what operation? If I'm saying find a common factor.
Simplest form.
Simplest form. Okay. That's what we want to get to. But factoring represents what operation?
To use what it's called.
Yeah, 4 choices. Addition, subtraction, multiplication, or division. You're on mute.
Division.
Division, perfect. Okay. So as you said, simplest form. So I want to take 6/8 and turn into simplest form. So I'm going to look for a number that divides both into 6 and 8. If I have one, then I can simplify. If I don't have one, there's nothing I can do. So in this particular case, if I look at 6 and 8, because I've been doing this for a while, I recognize that the number 2 divides both into 6 and 8. Okay. So therefore now we can do 6 divided by 2, which gives us 3, 8 divided by 2, which gives us 4. And this is the answer that we're looking for. Okay. So at the end of every problem, that is not just if I'm asking you to do it, at the end of every problem, we always make that scan. We always look for an opportunity to simplify. If we have it, we take advantage of it. If we don't, we leave it alone. All right, let's move on to 11. Ariana, go ahead.
Um, 11 is 12/6. I mean 6/12.
6/12. All right. And 6.
And simplified, it'd be 1/6.
Do that again.
It would be 1/6.
How'd you get that?
I divided 12 by 6, and it would be 1/2.
Okay. Justin, keep it on mute unless you're answering a question, okay? So what we have, so Ariana, what you just did is common, right? Which is one of the reasons I tend to do this, right? Even though I've been doing this for thousands of years, I'll tend to write those numbers in place just so that if a fly flies by and disrupts me and I come back to the problem, I'm really clear about what it is that I'm doing. And I don't lose my train of thought. And it also stops me from processing too quickly, right? So, which is what you did. You completely knew exactly what to do, but you kind of processed it quickly. And so you ended up with what would have been the wrong answer, even though you perfectly knew what to do, right? And so that ends up happening a lot when we take assessments. We know exactly what we're supposed to do, but we're kind of rushing, right? And so we do that mental process, that mental math, and then we get an answer wrong. And then when we get our paper back, we're like, oh man, I knew what to do. Yeah, but you didn't do it, so you lost those points. So the way to avoid that is to, again, put some notes for yourself to make sure you do it correctly, right? So I'll use these divide by 6, top and bottom, and I'll move from there. All right, so when we have common denominators, no sweat, right? Everything is easy. We just subtract or add the numerators and we keep it moving. Now, when we look at question number 12, don't have like denominators, but we spent 2 weeks preparing for this possibility. So we're not going to be stuck. All right, so what do y'all think we do? 2 different denominators, what are we about to do?
And we have to find a common denominator.
Yes, have to find a common denominator. Ash, I know you probably want to contribute, but for whatever reason, your mic, we're not hearing it. So I'm not sure what's happened this week. You were perfect last week. Sometimes logging out and logging back in may fix the mic issue. Okay. All right. So common denominators of 3 and 5.
15.
15. All right. So we're going to convert 2 over 3 to some with a denominator of 5, and we're going to convert 1/5. I said 5 to a denominator of 15, and we're going to convert 1/5 to something with a denominator of 15 as well. All right. So to get from 3 to 15, we multiply by 5. So therefore, we multiply 5 times 2, and we get 10. Same thing over here. We're looking at multiplying by 3. And again, I didn't do it on top, but I do use these little signs to sometimes help me. So I get 3 over 3, and then 3 times 1 is 3, 5 times 3 is 15. So those are my 2 fractions. So basically this becomes 10 over 15 minus 3 over 15, which gives me 10 minus 3 is 7, and 7 over 15 is my answer. So now again, Justin, what do we do at the end of each question? What are we trying to do?
We're trying to make it small, make the fraction smaller.
Right, if possible, right? If possible. So do you see, do we have a common denominator between 7 and 15?
No.
Nope. All right, so we're done then. No common denominator, no simplification. Okay. Posey and Bami, please turn your cameras on. All right, number 13, the sum of 3/8 and 1/3. So we're going to follow the same exact process. We have 3 over 8. And we have 1/3. Posey, I'm not understanding what I'm seeing right now. Please fix it. So someone tell me what's the common multiple of 8 and 3? Ash, I still didn't hear it.
Oh, 24.
24, thank you. All right, so each of these will end up being something over 24. All right, so to get to 24, we multiply by 3, so this will be 9. To get to 24, we multiply by 8. So 8 times 1 gives us 8. So our new fractions are 9 over 24. And we're taking the sum plus 8 over 24, which gives us 17 over 24. Okay. All right, any questions on that? Okay. All right, let's keep moving then. Okay. So for number 14, word problem. We'll walk through it real quick and then see what we need to do this week. I'll read it and we'll go from there. This weekend, Derek planted seeds in his garden. 1/8 of the seeds were beans and 1/6 of the seeds were carrots. What fraction represents how many more of the seeds were carrots? Okay. So let's read that again. This weekend, Derek planted seeds in his garden. Boom. 1/8 of the seeds were beans and 1/6 of the seeds were carrots. What fraction represents how many more of the seeds were carrots? All right. So wow, look at what we talked about earlier, right? Which is the larger fraction, 1/8 or 1/6?
1/6.
1/6. Good. All right. So, and what operation do we need to perform here?
Subtraction.
Subtraction. Why do we know that?
Because it says how many more seeds?
How many more? Okay, good. So one of the things in math is getting and understanding the vocabulary of math and how words map into operations. Okay, this is very important. One of the things that I sometimes see with students is they will try problems where they add in, and then if it does, the answer doesn't seem right, then they'll subtract. Answer doesn't seem right, they may multiply. Answer doesn't seem right, they may divide. And I automatically know that that student isn't well aware of how words and operations match together. So we actually will do that one day, but for right, so one of the things, and you probably should just put this into your notebooks. I always do this. We do have a lesson in our regular program where we talk about that. And what we try to do is we create a chart and we try to figure out how many different ways can a problem tell us how to do a particular operation. So if I was creating your chart for you in your notebook right now, I would probably write down many more, or how many more, I should say. And that tells me I'm performing a subtraction. Okay. Just to see how this works. Somebody tell me something else that tells you you're subtracting. What could be another word? And Ash, you know what? If you can put your answers in the chat and I'll try to be aware of it.
Another word is less than.
Less than.
More than.
Different.
Good, y'all look great. Then we have our regular things. What about different? Well, somebody said different. I'll just put difference. Let's put difference. All right. Difference would tell us. More than, less is one version of subtraction that's different from less than in a way. Because if I say 6 less 4, right, and I say 6 less than 4, that's actually two different things. Okay. And actually, based on that, let me just take this out of here and we'll put it in the addition side. Because if I say 8 more than 6, I'm actually adding. Okay. So that's again, we're gonna segue a lot as I teach, because when we have opportunity to make connections to things, I'm going to do it. All right. So we have 1/6, right? It's coming back to this 1/6 minus 1/8, because again, we said earlier, we know that 1/6 is larger. And then even the question, what fraction represents how many more of the seeds were carrots? So we know the carrots are larger, so we're going to subtract the fraction of the beans from the fraction of the carrots. Just going to do this quickly. Lowest common multiple of 6 and 8 is again 24. So this will be 8 over 24 minus 6 over 24. And again, for the new people, if this feels like it's moving really quickly for you, in our lesson 1 and lesson 2, we kind of set the foundation of how to find equivalent fractions. So there may be points where we move a little quicker. And this will give us 2 over 24. And coming back to my favorite person, Justin, do we leave it at this point, Justin? 2 over 24?
You could go lower.
I could go lower. What would I use to go lower?
To go lower, you would need well, actually, I think you should sing.
I should leave it the same. So Justin, did you ask yourself that question that we always ask ourselves? And that question is there a common factor of the numerator and the denominator? Which means, is there a number that goes into the numerator and also goes into the denominator?
Well, I was thinking of 14.
So remember when we talked about this, when we talk about factor, are we multiplying or dividing? You're muted.
Dividing.
Dividing. So we're looking for a number, not that multiplies to get 14, but divides into 2 and divides into 24. 14 doesn't divide into 24 evenly, and 14 definitely doesn't divide into 2. So we're looking for numbers that divide evenly into those numbers.
A number that would divide evenly into the numbers would be 2.
It would be 2, okay? So 2 divides into 2, and 2 divides into 24. So 2 divided by 2 gives us 1.
1 and 12.
112. There you go. Okay. So that's the process. So that's the question. Same question, same process. I'm looking for a number. Do I have a number that divides it evenly into the 2 numbers, into my numerator and into my denominator? It has to be the same number. It has to be an even division. Can't be something where we're left with a remainder. Can't be something that turns into a decimal. It must be something that leaves it just as a whole number. Okay, and again, it's a function of factoring, and factoring is division. Okay, so all those things kind of connect. All right, let's move on. All right, so with this one now, we're looking at numbers that are, just trying to see which numbers are true, which ones are not. We can kind of do this mentally. In all of these problems, what would be the common denominator, people? You got 10 and 100, 10 and 100, 10 and 100. What's our common denominator?
It would be a 100.
It would be 100. All right, someone said 10. The problem with 10 is if we have 100, right, as our denominator, to get to 10, we're dividing by 10. That means we have to divide all these numbers by 10. If we divide these numbers by 10, we end up with decimal numbers. So when we're dealing with fractions, we don't really work with decimal values. Okay, we do what we have to do to make the numbers whole numbers in our numerator. Okay, and even if we ended up with a number that was a decimal in the numerator, let's say 1.5 over 10, and you ended up with an answer for whatever reason that looked like that, we would normally have to change this to 15 over 100. And I'm not going to go into exactly why it becomes that, but we're never comfortable with having a decimal point in our numerator. So if anything that you're doing is forcing you to get a decimal in the numerator, you want to go in the opposite direction. So in this case, we want to multiply all of these denominators of 10 by 10, because even if you look at your answers, all your answers are in versions of 100. All right. So real quick, I'll just do this quick. If I'm doing this, this becomes 30 over 100, and 30 plus 15 is not 18. Okay. Over here, this becomes 40 over 100. 40 plus 32 is 72. Over here, this becomes 70 over 100, and 70 plus 2 is not 27. And last one, 60 over 100, 60 plus 27 is 87. And so we end up with equations 2 and 4 as our solutions. So some of this stuff is actually coming from like either diagnostic exams or, practice state exams. So especially these multiple choice questions, just think about, if you need to, just think about it a little bit before we move forward. Make sure you get it, and then we'll move from that point. Okay. And again, we're kind of speeding through some of these things. We'll slow down a little bit right now to take a look at improper fractions, or I should say mixed numbers. So one of the things that happens is, how do we deal with improper fractions? Different teachers have different ways of doing this operation. And I wish we were like in a traditional classroom setting. Actually, we could mimic it, and maybe we'll do it when we get to the really sticky part of subtraction. So to me, these are the easy parts. Now, some teachers will.
I want to say something.
Yes, Justin.
Well, I kind of understand it, but here's the thing. I always get confused if there's a number that you get that's higher than the denominator.
Okay, we talked about that when we looked at improper fractions. So you have notes, right, Justin? Do you take notes, Justin? All right, so you should have your notes from the first session. All right, so I'm gonna ask you when we're done with this, to go back and take a look at those notes from the first session. Again, we'll practice it a little bit here, but the first session is where we really went into it and really kind of explained it. All right, so let's take a look at 16. So in 16, we have 2 and 11/12 plus 7 and 11/12. So again, this goes back to our denominators are the same again. So we know we'll just need to add the numerators together, and then we can also add the whole numbers together. So this is going to leave us with 7 and 2 is 9. And then we'll have 11 and 11. So voila, look at that. This is exactly what you were talking about, Justin. We have 9 and 22 over 12. So what this is saying is that with this particular 22 over 12, my whole is equal to 12, but I actually have more than my whole. Okay, I have more than a whole. So matter of fact, what that means is I can pull out an entire whole piece from this. And the way we do that is just really through subtraction. If my numerator is 22 and my denominator is 12, if I think about it, I can really break up that denominator or that fraction into 12 over 12 plus 10 over 12. And that's my 22 over 12. Now, where did the 12 over 12 come from? Once I realized that I have what we call an improper fraction, because the numerator is larger than the denominator, I want to pull a whole. A whole is equal to 1. So to write a fraction as a whole, I'm writing that fraction with the same numerator as the denominator. So in this case, 12 over 12 is equal to 1. So once I pull out, and this is why I'm breaking it up into 2, once I pull out that 12 over 12, I'm left with 10 over 12. This 1, so now I'm going to evaluate this. 12 over 12, again, is equal to 1. And then 10 over 12 is, again, 10 over 12. All right. So we're going to do this in stages. So what I'm now going to do is I'm going to add, let's go over here. We're going to actually work on the side if we don't have enough space over there. So I'm going to take this 9 that I have over here, and I'm going to add it to the 1. So now this gives me 10 and 10 over 12. I'm almost done. I see that I have a common denominator here of 2, of common factor of 2, I should say. So I can divide top and bottom by 2. So I'm going to do that. So 10 divided by 2 is 5. And 12 divided by 2 is 6. So I'm going to divide top and bottom by 2. And this becomes my final answer. Okay. Now, some people say divide the denominator into the numerator. Again, it'll be effectively the same thing, right? But we can easily understand it the same way as a addition or subtraction of one fraction of a whole from whatever that improper fraction was. This one here is not so challenging. We have 8 and 3 over fifths plus 8 and 1/5. We're going to do 16 and 4/5. So we don't have that situation here. So this is pretty simple. All right. I'm just going to go over to the, usually we save the right side for the next week, but just to give us some more practice with this, let's do this first one here on the right side. So what time was it? 5:48. Okay. So I'm going to give y'all 2 minutes to give me an answer for this. So Justin, Bami, Posey, Ash, Vanessa, Ariana. Once you're done, post it into the chat.
Do we send it privately or to everyone?
You can send it to everyone. It's fine. It's up to you. Send it privately too, but you can send it to everyone if you want. Okay. So Justin, just take a look at your numerator and your denominator. And tell me if you can go can you go deeper? Take a look at what we just did and look at how what we did compares to what your answer looks like. Bonnie, you have an answer for us? Miss Vanessa, you have an answer for us? All right, so let's go ahead and do it. All right, so we have 2 and 8/9 plus 5 and 7/9. Again, 8 plus 7 is 15. 15 over 9 and 7. So, Justin, what kind of fraction is this? 15 over 9. You're muted.
What did you say? Couldn't hear you.
What kind of fraction is this? 15 over 9. What kind of fraction do we do?
An improper fraction and a mixed fraction.
Well, just a 15 over 9. It's what you said
An
initially.
improper fraction.
Improper fraction. Are we allowed to leave answers as improper fractions?
No.
No. Did you give me an answer with an improper fraction?
For 15 over 9? I mean, 15 over 9?
Mm-hmm.
That would be... Hold on.
Well, let's just walk through it together. Remember, we said...
So your first number will be 1 for 1, and then after that, how many is left over?
Okay.
How much is left over is 6. 6 is left over, and the denominator is 9. So that would be 169.
Okay. You did. You good there, Justin. You did that all mentally. I saw the wheels clicking as you were working through that. So you took 15 over 9, and you said I'm gonna pull a hole from it. So I'm just gonna, for those who are not seeing it exactly the way Justin sees it, let's just kind of illustrate it. So Justin said we're gonna pull a hole out, which is 9 over 9. And after we pull that hole out, we're gonna have 6 left. And then that 9 over 9 is gonna be 1 and 6 over 9. So now we're gonna take this 7 and 1 over 6 over 9, and we're gonna add it together, and we get 8 and 6 over 9. Okay. So are we done?
Now we are done. Now we are done.
Are we? Did you ask yourself that last question, Justin?
Yeah.
You did? What question did you ask yourself?
What am I gonna do? Am I gonna do multiplication, division, or subtraction, or addition?
No, that's not the question.
I don't know. I really just did it mentally.
Right, but you stopped at 6 over 9. And we said something earlier with our answer, when we do problems and fractions, what form must they always be in?
They always have to be in mixed numbers. If it wasn't improper, you have to always put it in mixed number.
Okay, that's one of the rules. That's the thing. I know math has a lot of little rules, right? And part of what our struggle sometimes is putting all these rules together, right? So once we've gotten something once we've changed something from an improper fraction to a mixed number, even when we were using this rule before we had mixed numbers. So it's beyond mixed numbers. It's beyond improper fractions. What is it, that last little rule that says? What does it say? What must we do? What must we always check for? Anybody remember? Okay, so just to finish this again, I want you to kind of go back over the work that we've done today, Justin, so that you kind of see how that last step always comes through, and that's for everyone else as well. Notice what we always do at the last step. We always check to see if we have a common factor for our numerator and our denominator. So we're looking at this 6 and we're looking at a 9. Is there a common factor between 6 and 9? All right.
Yes.
Yes, there's a common factor between 6 and 9. What is that common factor?
Is it 54?
No,
Oh, I mean,
factor,
is it
factor, not multiple, factor.
3?
It's 3. So again, common factor. Factor means what? Division. So we're looking for a number that divides into 6 and divides into 9. If I said common multiple, then we're looking for multiplication. All right. So we're looking for a common factor. All right. So that common factor in this case is 3. So 6 divided by 3 is 2. And 9 divided by 3 is 3. So this is our final answer, 8 2/3. Bless you. Okay. So the same thing holds true for subtraction. Over here, again, same common denominators. So we can just subtract. We get 6 over 10. 5 minus 3 gives us 2. 2 and 6 over 10. Can we do anything with that? Miss Vanessa, can we do anything with that?
Repeat it again, please.
Can we do anything with the 2 and 6 over 10? Or is that the final answer?
No, you can do something with the 2.
Okay. So what could we do with it?
By 2.
Okay.
And that would give us.
You're trying to divide.
So 6 divided by 2 would be 3. 10 divided by 2 would be 5. So again, we're right, 2 and 3/5. So we're again reducing to lowest terms. Okay. All right. So we'll do this last one. Same thing here. Again, we're not doing much different. The denominators are the same. So we're going to subtract 3 minus 2 gives us our 1 over 5. And 6 minus 4 gives us our 2 and 1/5 is our final answer. Okay. All right. So that's going to kind of close it out for our first session. Just to take a look at what we're going to be doing next week. Yeah, some stuff. So this week we took a look at addition and subtraction, same denominators, proper fraction, as well as mixed numbers. So next week we're going to take a look at adding and subtraction of proper fractions and improper and mixed numbers with different denominators. Okay, so we see that coming up. 17 is just a more of same denominators, but we'll pretty much be starting around 18 next week, and moving forward from that point. We may do some review questions like we normally do, and then we'll move forward as far as 18. 18 is really going to get interesting, or next week is really going to get interesting when we take a look at the concept of borrowing and fraction and subtraction. That's the really, to me, that's the trickiest part of fractions in terms of addition and subtraction, is the whole concept of subtracting numbers when you have to borrow. Some teachers teach it one way, but I'm going to show you another way next week, to me, that makes a lot of sense and is a lot simpler than what is normally done in a lot of middle school classrooms.